Okay, this is the other free response question from 2016, question number 3. So part A says, does G have a min or a max or neither at x equals 10? So if for G to have, so this is what you would write, for G to have a max or min, G prime equals 0. Okay, and there's also would be a sign change. So let's say G prime equals 0 and there's a sign change. Okay, it's really important to write that part about the sign change. Okay, so when does G prime equal 0? Well, we have G right here. So if we take the derivative of both sides, we're just going to get that G prime equals f of x. That's the second fundamental theorem of calculus. So where does f of x equal 0 and have a sign change? So this is the graph of f. And so, for example, if you look here at -2, it equals 0 right here, and it was negative, and then it was positive, so there would be a sign change. But they're not asking at -2, the question is asking at x equals 10. So if you look over here at x equals 10, okay, it definitely equals 0, the y value, except that there's no sign change because it was negative, and then it was negative. So that means that's a place where the slope equals 0, but it's neither a max nor a min. So you would write, there is neither a max nor a min at x equals 10. And you're justifying it by saying because there is no sign change. Or you could say because it's negative and then it's negative and no sign change. But you have to use the words because there's no sign change. So this question was worth 1 point for this. Whoop, I just lost my page. Sorry. Okay, I don't know what just happened there, but that would be the answer for that. You would say because there was no sign change. Okay, sorry for that confusion. I don't know what happened to that whole slide, but okay, we're up to part B. So does G have a point of inflection at x equals 4? So you would say G has a point of inflection, but you're going to write it out when G double prime equals 0 and there's a sign change. Okay, so we know that G prime equals f of x. So therefore G double prime equals f prime of x. So if we want to know when does G double prime equal 0, we really want to know when does f prime equal 0. Okay, so f prime is going to equal 0 wherever there's a slope of 0. So remember, this is the graph of f, and we're looking for when is the derivative going to be 0. So for example, if you look at when x equals 0, right here, and we look up here at 4, the tangent line to the curve will be like this, and that would have a slope of 0. This also will happen here, happens here. I'm not saying at 2 because, oh no, at 2 also. All these different places, and there's a sign change. So does the graph of G have a point of inflection at x equals 4 is the question. So right here, yes, that's one of the places that we chose. And you would say, yes, there is a point of inflection at x equals 4 because f prime equals 0 and there's a sign change. Or you could say it was, let me get another color, you could say it was increasing and then it was decreasing. As long as you do something to say that there's some sort of a sign change, you'll be good. And that was worth 1 point as well. Okay, now we're up to part C. So we're looking for an absolute min and an absolute max from -4 to 12. So remember, an absolute min or absolute max can always happen at the endpoints. So we're looking for g. So that means we need to check the endpoints of g of -4. We're going to do g of 12, and then we also have to see, are there any maxes and mins? And wherever there's a max or a min, we're going to have to add that to the list. Okay, so when does g have a max or a min? When g prime equals 0. But we've already said that g prime is equal to f of x, so we're really looking for when is f of x equal to 0. So f of x is equal to 0 right here at -2. So we're going to have to add that to our list. And it's, well, now over here at x equals 2, yes, it does equal 0, but there's no sign change. So there would be no max or min there. Where, for example, at -2, it's negative, and that's positive. Okay, and then at x equals 6, it's equal to 0, and there's going to be a sign change there, so we're going to check that. And at x equals 10, it's also equal to 0, but it's not going through the axes. So we're going to check these 4 values and find the biggest and the smallest numbers. Okay. So the first one I'm going to do is g of -4, I guess. So here's g. So that means g of -4 would be the integral from 2 to -4 of f of t dt. Now this is not the second fundamental theorem of calculus. There's no d dx in front of the integral. But remember, you can't have the bigger number on the bottom of the integral, so we're going to have to flip that. Put the -4 on the bottom, the 2 on the top, and then put a negative in front of the integral. So basically what this is just saying is what is the area under the curve from -4 until 2. So -4 until 2 will be this piece right here. So we're going to have this triangle, and we're going to have this triangle. So we're going to have a negative in front, and then let's figure out what the area is. So we have this triangle down here on the bottom, and so for that one we're going to have 1/2 the base, which is going to be 2, times the height, which is 4. So it's going to be half of 8, which is equal to 4, but keep in mind it's under the axes, so it's a -4. Okay, and to that we're going to add the area of this big one right up here. Okay, so we're going to have 1/2 the base, which is 4, times the height, which is 4. So it's going to be half of the 16, which is 8. Okay, so we're going to have a -4. So g of -4 is equal to -4. Okay, we're going to have to do this 3 more times. Okay, so let's get rid of all of this. Okay, what might be a good idea is just to label this -4 in case we're going to need it again, and this one's going to be 8. Okay, so we don't have to keep doing it over and over. Alright, so the next one is going to be g of 12. So g of 12 is going to be the integral from 2 to 12 of f of t dt. Okay, so we're going to go from 2 to 12. So let me get another color here. So here's 2. So we have this triangle, and then we're going to have this triangle. Okay, now you can see that the triangle that goes from x equals 2 to x equals 6 is the exact same size as the triangle that goes from x equals 6 to x equals 10. So one's positive, one's negative, and they're going to cancel each other out. So all we have to do is to find the area of this triangle down here, which is below the axes, so it's negative. So it's going to be 1/2 the base times the height. So half of 8 is equal to -4. So g of 12 is -4 as well. Okay? So I'm just going to mark color. This piece over here was negative 4. Okay. Whoops. All right, next let's do g of negative 2. So g of negative 2 will be the integral from 2 to negative 2. But we can't have the bigger number on the bottom, so we're going to flip it and put a negative in the front. So we're going to have a negative, and then we'll figure out the area. So we're looking from negative 2 to positive 2. That's going to be this piece right here, which we already know is 8, so we don't have to redo that. So we have a negative 8 for that one. And now finally we just have to do g of 6. Okay. So g of 6 is going to be the integral from 2 to 6. And from 2 to 6, we're talking about this triangle right here, which is going to be 1/2 the base times the height. So we're going to get half of 16, which equals 8. Okay, so now you're going to look at all of these values. So first of all, alright, so let's finish it and then I'll tell you the point values. So you can see that the smallest number here is negative 8. So we're going to say that the absolute min is negative 8. And you can see the biggest number here is positive 8. So you can say the absolute max is 8. So it's not asking at what x value is this happening. It's just asking for you to find the absolute max and min. So your point values are, if you just even considered g of negative 2 and g of 6, you got 1 point. If you considered the, whoops, oh my god, that same thing happened again. That just happened. Oh, there we go. Okay, if you considered g of negative 4 and g of 12, you got a point. You didn't even have to figure out what it is. You just had to write it down that you're considering it. That was a point. And then if you got all of these if you got the 2 answers and you showed all your work for everything, that was another 2 points. Okay, and that completes part C. Okay, so the question is, when is g of x less than or equal to 0? So g of x is this thing right here, and so when is that going to be less than or equal to 0? Well, one thing that we talked about before, well, if we just go back to the previous problem, when we did g of negative 4, that was one of the values that we just tried, g of negative 4 equaled negative 4. So that's definitely less than 0. If we just look at g of negative 2, we also did that one from the previous problem, we got negative 8. So that's definitely less than 0. So far we have an interval going from negative 4 to negative 2. And we can continue with that just based on all the different values that we've already used. So we know that if we just did this triangle right here, that's going to be negative. If we do that piece and this piece, we're going to get a 0. So far the interval that goes from, we'll update this, but from negative 4 to 0, that would definitely be an interval when you're going to get negative numbers or 0. But when we did, if we go all the way up to over here, which is 2, so if we did g of 2, you would get the integral from 2 to 2, using this right here. And from 2 to 2 is no space at all, so you're also going to get 0. So in fact, it's really the interval that goes from negative 4 to 2. However, remember when we did g of 12, we got negative 4? So that's going to happen right here for this piece here. If we just do it from 10 to 12, we'll have that negative piece. So it's from negative 4 to 2, and it's going to be from 10 to 12. This one's a little bit more difficult. I mean, you could try every single number if you actually had time. And this was with 2 points for the interval, so this interval was worth 1 point, and this interval was worth 1 point. And that finishes that question. Now that was a long one. That was over 15 minutes.